So in today's session, we are joined by Itay Malka, a cloud solutions architect from Cloud. Itay will be teaching us about the 4-score scaling methods in autoscaling on Azure. This session will run for approximately 60 minutes with time for questions. Okay, at this time, I will let Itay step in and he can take over on my screen.
Okay, so thank you, Rebecca. Hi, everyone. Nice to meet you all. And welcome to Azure Kubernetes Service autoscaling methods on Azure. So my name is Itay Malka. I was born in Israel. I love C, music, and especially food. And I'm also a cloud solutions architect at Cloud. So who we are? So Cloud is a global cloud MSP that specializes in working with tech companies, including startups, SMBs, ISVs, and unicorns. We help plan, build, and run cloud-based solutions by offering zero-cost consultancy, training, and 24/7 tech support, and cloud cost optimization. So here is the agenda and what are we going to do today. So first, I want to start by saying that I will leave time for Q&A at the end of the webinar and between the different parts. So the first is the scaling options in AKS. The first, manual scaling, then Cluster-Autoscaling, horizontal Pod Autoscaler, which is known as HPA, and KEDA, which is the event-based scaling in Kubernetes. And then we will start from the Azure resources brief that I already created before. So actually, when we're talking about the scaling options in AKS, especially, there are 4 core scaling methods you may use to increase or decrease the amount of compute resources. I'm going to talk about each of them, what are advantages and disadvantages, and when to use them. So let's move to the resources brief. So now I'm logging to my Azure portal. As you can see here, I already created a resource group named Itay, and inside it we can find 3 resources. The first one is Itay AKS, which is the Azure Kubernetes cluster, AKS cluster. The second one is the Itay ACR. This is the Azure Container Registry. And the last one is the Webinar SB. This is the Azure Service Bus. We will talk about it in the last part of the webinar, which is the event-based scaling, talking about in the KEDA section. Okay, and now I want to start from the manual scaling. So let's start. All of our Kubernetes applications actually runs and deploy on compute resources. In AKS, all applications run on VMSS, which means virtual machine scale set. This is actually a set of nodes. There's compute resources called agent pools in Kubernetes, and this agent pools represents a set of nodes with the same configuration, like VM size, CPU, memory, etc. So we will start from manual node scaling. I want to move to my terminal. So now I'm currently logging to my cluster, to my AKS cluster, Itay AKS. So by running the command of kubectl get nodes, now I can see the current nodes that I already have inside my cluster. Sorry for the delay. It will take a while. Great. So now I can see that I already have only one node in my cluster, and we will see it in the portal in the next few seconds. Now I'm going to my AKS cluster. Sorry. on the Azure portal by clicking on my AKS cluster. If I'll go to the node pools, then I can see that I have only one node pool. And as I said before, a node pool is a set of nodes that share the same configuration. So if I will click on agent pool, guys, sorry. If I click on the agent pool and see here, now here I can see all the properties, all the details regarding the nodes that will set inside this node pool, the VM size and CPU, memory, all the other details. And if I click on nodes, now I can see exactly the node that already deployed to my AKS cluster. So now I want to show you how can I scale up manually the number of nodes inside my node pool in my cluster. So I'm inside my agent pool, and by clicking here on scale node pool, you can see that I have actually two scale methods. The first one is the manual. I can control the amount of node manually from 1, and the maximum is 1000. So I just can type here 2, and by click on apply, then I will be able to see that another node has been added to my cluster. I will not do it because it's so simple and it will take a few minutes. But I want to talk about why would you use the manual node scaling. So actually, if there is no constant need for flexibility, and for example, I want to limit the amount of nodes in my cluster, and in addition, it can also be reflected in the cost aspects because I know my fixed cost per month, depending on the amount of resources I allocate. So if I know that I have only one node inside my cluster without any automatic scaling method, so I can make sure about what I pay every month. So this is the usage of manual scaling in AKS, but actually, as you can see, and we'll talk about it in the next few seconds, and in the next few minutes, this is the second option. This option is recommended. This is the autoscale, and we will talk about it. Now, Now I want to talk about manual scaling for pods, for our replicas inside my cluster. So for this example, I will deploy a deployment which contains one pod to my cluster with Nginx image. By the way, I will use for all deployments and for all parts in this webinar only basic Nginx image. So I prepared and created a directory to this webinar named AKS Scale Webinar, and I divided into 4 parts. As you can see, directory per each part. For example, manual scaling, CADA, HPA, and Autoscaler, and the Cluster-Autoscaling that we're going to talk about. So for now, I'll click on manual autoscaling, and as we can see here, I have manual scaling deployment YAML file. And I will open this file. Great. So now, as you can see, a simple deployment, which represents a Kubernetes resource with one container inside it, with the image of basic image of Nginx. And all what I want to show you is how we can manually scale the number of pods that created from this deployment. So if I go back to my terminal, cd to the manual scaling, And now I want to run the command. I want to create a namespace before for this manual. So kubectl create an S, which means namespace, manual scaling. Great. And now I want to deploy the YAML file to this namespace by running the following command: kubectl apply -f this YAML file -namespace manual scaling. Great. So now, as I can see that there is a deployment has been created inside the manual scaling namespace. So let's view it. kubectl get deployment namespace manual scaling. And great, we can see here deployment named manual scaling with one pods are in a running state, in ready state.
Hi, Itay. Do you mind zooming in?
Sorry?
It's coming in quite. Do you mind zooming in? It's coming in very small. The audience can't see.
Okay. One moment. Sorry. Great. Okay. Can you see my screen, right?
Much better.
Yes, much better. Thank you.
Thanks. Great. So I'll go inside the directory again. And as we said, kubectl get pods namespace manual scaling. And I can see that there is one pod created from the deployment that I already deployed to my cluster. So now I want to show you how we can easily scale manually the number of pods that created from this deployment. So let's get the deployment again because we need its name. And now I want to edit this deployment and change the replica parameter, the value of the replica parameter. So this value is actually points to the number of the pods that created from this deployment. So I can kubectl edit deployment, the name of the deployment and the namespace. And now I can see all the YAML actually that I deployed to the cluster. And if you can see here, this is the replicas parameter. And actually the value now is 1. So I will set the value to be 3 for this example. I will save and quit from the file. And we see that the deployment named manual scaling has been edited. So let's again get the deployment. And now we can see that there are actually 3 pods in a running state. And let's view the pods state, kubectl get pods. And great, we have 3 phases or 3 replicas of our application named manual scaling, and that's the way that we can manual scaling our the amount of pods inside my cluster. So this is the easiest way to scale pods. Okay. Now I want you to talk about the cluster autoscaling. As you can see and you can read, In this section, I will show you how we can autoscale the number of nodes when we try to deploy resources, which mean pods, with more hardware resources than the node has. And it's really important to understand it. In order to illustrate it, I already created two YAML files to deploy two simple pods with one Nginx container inside each of them. And by default, the Cluster-Autoscaler checks the metrics API server every 10 seconds for any required changes in node count. And that's because it has to know if it has to increase or decrease the number of nodes accordingly. And in addition, a node that passes a threshold for no longer being needed, so it means no scheduled events, for 10 minutes by default is scheduled for deletion. And I want to start from the question that what would you use the cluster autoscaling? So you can easily scale automatically the number of compute resources, which means the nodes of your cluster on demand. If you will need to add another pods and the pods requests set of hardware resources from the node, you will not worry about the resources limitations. Also, you will need to limit the amount of nodes in cluster. So now I want to show you in Azure portal. I will click again on the scale node pool, and now I want to change to the second scale method. This is the autoscale, which means the cluster autoscaling in AKS in Azure. So now by enable or allow this scale method, the autoscale, as I can see here that I have another option. Now I can limit from up and from down both of the scales, so or scale up or scale down. I can limit the number of the nodes that will be added to my cluster. So from down, I can limit that I want minimum one node in my cluster. This is my requirement, for example, and maximum of 5 nodes, because try to imagine any scenario that your cluster will autoscale and scale up, scale up, scale up, and then what? You will get, maybe there is a chance that you will see in your cluster more than, I don't know, 100 nodes. So if we're talking about the cost aspect, so it's very expensive. So we don't want to use it, and that's the reason why we put the limitations. Okay, so I will click on apply to apply the new configuration. And now I want to go back to my directory, to the cluster autoscaling directory. And as I said, there are two YAML files, pod1.yaml and pod2.yaml. And let's view the files. Great. As we can see here, I actually want to create one pod named frontend and one container inside the pod with the basic Nginx image. And this section is the most important thing that we have to understand when we are talking about cluster autoscaling, because the requests resources, it means that my container or my pod will request from the node inside the node pool these resources. 1 giga of memory, okay, that's fine, because my node actually has 7 giga of memory. And the CPU, I'm trying to request 1 vCPU. And let's view the other file. Great. And the second pod is actually requests the same resources. Again, 1 vCPU. And now I'm expecting to get an error. Why? Because if you remember, and I go back to my portal, this is the size of my node. And let's see what's mean. So I have 2 vCPUs per node and 7 GB of RAM. So actually it's not possible, and we want to see what's the behavior of the Kubernetes when we are trying to request more and more resources, more than the limitation. Okay, so as I said, I cannot deploy 2 pods on the same node inside my cluster, because we'll reach the limit, and then the scheduler will not be able to assign another pod to the node. So let's see if our cluster autoscaling, once it's enabled, what is the behavior of that. So now I will go back to my terminal. CD cluster autoscaling. Let's clear the screen. Great. And now I will start from create another namespace. ClusterAutoscaling. Great. And now I want to deploy 2 pods to the namespace. So kubectl apply pod1.yaml. Let's create it. Great. The pod has been created. So let's kubectl get pods -- namespace ClusterAutoscaling. Sorry. Right. And now, as we can see, there are a pod. Just a moment, I want to fix something. I will delete the first pod because I deployed on the wrong namespace. Great. So now, as we can see, I have the first pod named frontend, and it is actually in a running state. So that's great. So now, if I will try to deploy the second pod, let's see what happened inside my namespace, ClusterAutoscaling. Created. So let's view the pod state again. And now, as we can see, that the pod is not in a running state, is in a pending state. And now I want to view the pod state, and we will click the command kubectl describe pod with the name of the pod, backend, namespace ClusterAutoscaling, and let's see. Great. So as you can see here, actually the pod, the pod or the scheduler, more than that, failed schedule or assign the pod to the node because there are no more nodes that are available because of insufficient CPU. We try to request more than 2 vCPUs, but I have actually only 1 node with 2 vCPUs. So here is a limitation. And then we can see that there is a scheduler or a trigger for the autoscaler in the cluster to add another node. As you can see here, now I have 2 nodes, and after the node has been created, then the pod is actually scheduled or assigned to the new node in the cluster. So let's view the state of my nodes in my cluster. And as you can see here, actually we got another node to my cluster, and that's because of the cluster auto-scaling. If I'll go back to the Azure portal, now I will click on node pools. As you can see, I have 2 from 2 nodes in a ready state. And by clicking on the agent pool and nodes, you can see there is another node that headed to my cluster. So that's great, and that's how Autoscaler actually works in AKS. Okay, guys, before I will talk about HPA, there are any questions regarding the previous 2 sections? Great. So now I want to talk about the horizontal pod autoscaler. If we talked about nodes in the previous step, so we talked about a vertical autoscaler because we scale the number of nodes. We scale up and scale down. And we were talking about pod autoscaler, which means the HPA. We are talking about a horizontal autoscale, which means scale out and scale in. And scale out in case that I want to increase the number of pods in my cluster, and scale in case that I want to decrease the number of pods in my cluster. So in this section, we are going to deploy 2 Kubernetes resources to our cluster. The first one will be a deployment, and the second one will be the HPA, the horizontal pod autoscaler, that points to the deployment and scale on demand. And for this, let's start by creating another namespace named HPA, as we did in the previous steps. So let's clear the screen. kubectl, create namespace HPA. Great. And now I want to deploy my deployment file, but I want to show you that before I will do it. So here in the HPA directory, you can find the HPA app deployment.yaml. I will open this file. Great. Okay, so now I have a deployment named HPA app with, again, 1 replicas, which means run 1 pod, and 1 container inside the pod with the basic Nginx image and all the other details. In addition, what I'm going to do, I will deploy another Kubernetes resource, a service type load balancer, because I want to expose my Nginx web server to the internet. So that's the reason. So let's deploy kubectl apply HPA inside namespace HPA. Great. So the deployment has been created and also the service. Now I can view the deployment. Okay, so here's my deployment. It actually created 1 pod, as I said, 1 replicas inside the deployment, and I can view also my service. Great, and here's the external IP. So now, just to clarify, I want to go to the browser, enter the public IP, and here, as you can see, welcome to Nginx. It means that I already deployed an Nginx server and exposed it to the internet over this public IP, over port 80, which means HTTP. Great. For now, before I will show you how HPA works. I want again to ask the question, why would you use the HPA? So HPA actually is a great tool to ensure that critical applications are elastic and can scale out to meet increasing demand and scale down actually, as well scale down to ensure optimal resource usage. HPA makes scaling decisions based on the observed CPU utilization values of pods that are part of a Kubernetes controller. What else? You can easily scale automatically the amount of pods that serve your application. Imagine that your web application deployed on pods in Kubernetes. However, you will not always need a large amount of pods, as there is not always a large amount of users and load on the server. So in this case, the HPA can help and solve the problem. So how we can create and deploy our HPA on the cluster? So we have basically two ways. The first one is to create it by create a YAML file with the HPA resource. And the second one is by running a kubectl command to create it for us. So let's create it now from the kubectl command. Great. So the command is like that, kubectl autoscale. I want to autoscale my deployment. The name of the deployment is HPA-app. And now I want to specify the CPU percent. For this example, I will set the CPU percent to be 3, and I have to set the min, which means the minimum pods, minimum number of pods, as we said see in the node section. So it's the same. I have to set the minimum nodes. I will set it to be 1, and the maximum will be 10, for example, inside my namespace, which means HPA. So I actually, in this command, I defined the HPA to increase the number of pods by 1 when the CPU percentage will reach 3% or more. In addition, the HPA defined, as I said, the minimum and the maximum number of pods should be running. We can call it the limitations. And to view the HPA, now I will deploy it. And to view the HPA, I can run again the same command, kubectl get HPA with specify my namespace. And now we can see that here is my horizontal pod autoscaler, and the reference is my deployment named HPA app, and the targets is actually represents the CPU percentage. And let's click the command again. Great. Now I can see that the CPU utilization of the pod, or of the deployment, is 1 from or of 3%. So I have to find a method to overload my server to cause this and affect the CPU utilization of the server, so it can be increased, and then I can view how HPA actually works. So now to test our HPA, we will need to, as I said, to load the deployment or the pod, the server, so we can increase the CPU percentage. And since I'm using Nginx image, I prepared a simple script which sends multiple requests to the server, and it should increase the CPU percentage, and then we will see the HPA works. So for that, I will take the external IP. Now I will go back to my directory, multiple. I will edit the file. And this command should send multiple requests to my server to load and make the CPU utilization to be high. So I will save. Great. Now I want to run the script multiple times. So here's the first one. We send a lot of requests. Again. And again. And now I can view real-time my HPA. As we can see, the CPU utilization is still on 1. And if we will wait a few seconds, we can see the CPU utilization comes higher and higher. Sorry, let's try it again. I will just verify the IP address. Great. Let's verify. Yeah, this is the IP address. Okay. Great. Now we can see that the CPU utilization comes higher to 7%. And I define that each pod or each replica can handle only 3% of CPU utilization. So it means that the deployment will create, or the HPA will add another 2 pods to handle 7% of CPU utilization. And this is exactly what we can see here. The number of replicas has been changed. It was 1, and now it changed to 3. So if I will type the command of kubectl get pods, let's see it. Now I can see that I actually have 3 pods in a running state that to handle all the requests of my deployment, of my Nginx server. So that's exactly how HPA works. It autoscale automatically, autoscale. It's scaling automatically the number of pods by any system metric that we can specify and we can define in our HPA. In this case, I chose to use CPU utilization, and that's the reason why we can see that the number of pods increases by 2. So any question regarding the HPA, guys?
We have a question here in the window from Rami. What are the different metrics that can be tracked by HPA?
Okay, this is a good question. This is a good question. Sorry, we have actually a lot of methods to scale or a lot of, how can I call it, metrics based on them to scale or auto-scale the number of pods in my cluster. So the first one and the basically one is the CPU utilization. Next, we can, based on the requests to our server, to our pod, we can based on the memory, and we have another methods we are going to talk about in the next section. This is the event-driven based. So this is the CADA, and then we have multiple and a lot of options to auto-scale our pods in the cluster. Great.
Thank you.
So here's the diagram of Autoscaler. As you can see, we have all the nodes inside our cluster, and behind it, we can see the HPA, the horizontal pod autoscaler, which can scale out and scale in the number of pods in our cluster, and it's no matter which pods and I don't know where it assigns to node number 1 or 2 or 3, and we can deal with it easily. And okay, so now we're in the last part of the webinar of the scaling options. This is the event-based scaling, and we are going to use CADA. So CADA, as you can see, is actually a Kubernetes-based event-driven autoscaler. With CADA, we can drive and scaling of any container in Kubernetes. And in this webinar, in this section, we're going to use the Azure Service Bus queue to implement the CADA event-based autoscaling. So before we'll start, what is Azure Service Bus? In one sentence, Microsoft Service Bus, Azure Service Bus, is a fully managed enterprise message broker with message queues and publish subscribers, subscribe topics, which means pub/sub. Who familiar with? And what is the prerequisites for using CADA? Is only one. We have to install CADA on our cluster. So I actually deployed CADA on my cluster. We can see it by type the command of kubectl get namespace, and we can see here that except the namespace that I created, we can find here the CADA namespace. This is a namespace that's created by when I'm installing the CADA package. And before we start with the demo, why should we use CADA? So CADA works alongside standard Kubernetes components like the HPA, which we just talked about, and can extend functionality without overwriting or duplication. With CADA, we can explicitly map the applications we want to use, event-driven scale with other applications to function, and this makes CADA a flexible and safe option to run alongside any number of any other Kubernetes applications or frameworks. And CADA's scalers represent event sources that CADA can scale based on, such as Azure Event Hubs, Azure Pipelines, Azure Log Analytics, and Azure Monitor, Azure Service Bus, and a lot of other public cloud services. There are multiple connectors. A lot of you can just view the CADA documentation later. So now I want to show you the deployments, what we're going to deploy. But first I will start with create another namespace, name CADA scaling, because I have a namespace named CADA. Great. Now I go back to the to my directory and go inside the CADA directory. And as we can see here, we have two YAML files. The first one is deploy app. Let's view this file. Great. And as we can see here, we actually have deployment, which will deploy only one pod, one replica, with one container inside it. With this image, this is a sample image, a .NET Worker service bus to handle and listen to all the messages in the queue. I will explain what we're going to show. And the second one is a secret. This is a secret. This is a Kubernetes resource that will represent the connection string to our service bus queue. And the second, file we can see here three Kubernetes objects. The first one is a trigger authentication to authenticate to our service bus and trigger in case that we have to trigger to increase the number of pods in my cluster. Then a secret again to the trigger authentication. And scale object. This scaled object is an object that created by CADA API, but it actually creates an HPA. It scale the number of pods again. And now, great, we can deploy, and then let's move on to the demo. Okay, so I already created a namespace, and now I will go to the Azure portal. I will show you my service bus. I go back to the Itay resource group, and here we can find the service bus namespace named webinar SB. By clicking on it, I can go to the queues entity in the left menu, and I will create a new queue for that. Great. Let's call the queue webinar queue and click on create. Great. So our queue is created. I will click on the queue. And now, as I said, I want to be able to listen to all the messages inside the queue. So I have to generate a connection string with the relevant permissions. So let's call the policy and grant them the manage permission. Great. And now we can see that we have the primary connection string. I will copy it to my dashboard. Okay. And if I will view again the YAML files, we can find here two values that we have to change. The first one, this is the environment variable, the queue name. So I will change the queue name to my queue, webinar queue, and then we have to get the connection string, but not the regular connection string. We have to encode it to base 64. So we can do it easily by using the command line. If I go back to terminal, I can type echo the connection string with base 64, and I can get this base 64 connection string. So I will copy the connection string, the encoded connection string, and paste it here. I will save the file. I will have to do the same to the second YAML file. So I open it, and again, here I have to change the queue name, webinar queue, and the base 64 connection string. Great, and I saved this file as well. Okay, so I just want to talk about the YAML files before I will deploy them on my cluster. So since this is the requirement of the base 64, there are multiple ways to encode them in this method, but I used the CLI, so it's really simple. The queue name, this is the name of the queue that I created. And another last parameter here in this YAML, this is the message count. So what is it? This is the value that represents the maximum number of messages a pod can handle. That is for every 5 messages or more in line or in the queue. So a new pod will be created for listening and handling messages. So this is my limitation. I just decreased the number to be 3, so we can see more and more pods that the KEDA actually will add to my cluster. I save the file again, and now I want to go back to my terminal. Get inside the KEDA directory, and now I want to deploy the files. So kubectl apply -f deploy app -YAML in my namespace KEDA. Great, created all the Kubernetes resources, and now I will run again the same command with the second file. Autoscaling. Great. So actually all the Kubernetes resources has been created. Let's clear the screen and see kubectl get pods in namespace KEDA. Oh, sorry. I deployed the file to the wrong namespace. So just a moment. I will deploy it again to the right. Sorry. kubectl get deployment KEDA. Okay, I will delete my deployment from this namespace. Great. and now I will redeploy them to the right namespace. Great, so deploy up and deploy autoscaling. Great, so now let's view kubectl. Get pods, namespace, keda, scaling, and there are no actually pods inside this namespace. Let's view the deployment. And as we can see, there are actually the service bus deployment with 0 replicas, which means 0 pods. So now what I'm going to do, I want to go back to the portal. And I want to go to the Service Bus Explorer. In this way, I can easily send a lot of messages to my queue. And then I'm expecting that my pods will listen and handle all the messages that I send to my queue from the portal. So I will send a message with a JSON message with body, hi, webinar people. Copy it, and I will send a lot of requests, one by one. Of course, that I can, these messages can be sent to the queue, not from the portal, and they will probably sent for the queue or to the queue from your application, from users' requests or something like that. And now let's see, before I will see the pods, I want to see the peak. In this way, I can see what is the active messages in the queue. It means 0, but I already sent the messages to the queue. So there is something, anyone or any pod or any VM that handling and listening to the queues inside, to the messages inside the queue. So let's run again the command of kubectl get pods, and as we can see that there is a pod that comes up in a running state, that actually this pod right now handling and listening to all of the messages inside my queue. And you just can to imagine that if I will send a multiple requests from any code or something like that, maybe, I don't know, 100 messages per second or per minute, there will be a lot of pods that KEDA using the HPA will create. So in this case, it's actually created only one pod because I sent not too much messages to the queue, and the value of the message count is set up to 3. So that's how KEDA works. That's how autoscaling works in Kubernetes, or especially in Azure Kubernetes Service. I just want to summarize. I will go back to the presentation. So we talked about 4 of them. We talked about the manual scaling, the Cluster-Autoscaling, HPA, and the event-based scaling. In this case, we are using KEDA. This is the diagram actually of how KEDA works. As you can see here, this is a great diagram how to implement it, how it actually works. Here is the KEDA. When I'm installing KEDA on my cluster, there is a metrics adapter, a controller of KEDA, and scaler. And in the right, we can see external trigger source. In our case, it was the Azure Service Bus. So anytime we have any external trigger, it will trigger the CADA listens to the trigger, then the CADA trigger any HPA in my cluster that created by CADA, and then the HPA will scale the number of pods in my cluster. And it's just amazing because we can connect our cluster and based metrics from any third party or any cloud service that we just can't imagine. And again, this is an amazing, and I recommend it to use it. And that's it. So thank you so much for coming to the webinar, and this time for Q&A. Thank you.
Thank you, Itay. If anyone has a question, feel free to unmute yourself and ask.
Thank you as well, Itay. While we wait for questions to come in, I'll just quickly, as we're a little bit over time, run through a little bit about the reactor. If you're joining us for the first time, the reactor program has 11 physical spaces located around the world. But right now, most locations are currently virtual. So if you happen to hear about the session today through another source, just know that we have these locations, including one in Tel Aviv. If you're joining us from Israel, we also currently are running virtual sessions. So depending on where you are located, we might have a session that works with your timing, your personal schedule as well. So definitely check out our calendar, which is at www.microsoftreactor.com. You can find us on Meetup. For each of our physical spaces, we have a Meetup page, so do check that out. You can search for us there. Again, Microsoft Reactor is the search. We have an email sign up if you want to get. We just send one email once a month with upcoming sessions for the following month. So aka.ms/reactor email sign up. And you can also follow us on Twitter at MSFT for any like highlighted sessions. As mentioned earlier on this call, we did record the session. It will be available and you will be able to find it on our Microsoft Reactor YouTube channel. It probably would take about 24 to 72 hours or so for that to load up there, but you can find that there, and also a bunch of other resources, previous content that we've featured through the Reactor program. So at this time, it doesn't seem like any questions came through in the chat. I think we can wrap the session up. Thank you again, Itay. That was great. I think that was a really good session and you covered a lot of material.
Thanks. Thank you, Rebecca.
Appreciate it. Yeah, thanks again.
Thank you, Itay. Great session. Like it.
Okay. Have a good one, everyone.
Thank you, Itay.
You too. Thanks.